Okay, here we go. Unit 6, Lesson 1, practice problems. So we got to reflect triangle ABC over the line x equals -3. Let me start with one of the GOATs of baseball, Mike Schmidt, third base, one of the best third basemen of all time. He played for the Phillies. Legend right here. Okay, so we got to reflect ABC, this triangle over the line x equals -3. I know you can probably tell my voice is a little off. So one of the things you can do is draw the line of reflection. So here is x equals -3. Okay. So all you need to do first is count off. So that's 1, 2. Here's A prime. C stays put. That's C prime. B is 1, 2, 3. So go 1, 2, 3. There's B prime. So draw x equals -3. Reflect each vertex A, B, and C over that line. Okay, so now we're here. Now we have to translate this image by the directed line segment from 0, 0, right here, to 4, 1. So we're going to go up 1 over 4. So this is the directed line segment from 0, 0 to 4, 1. So every point's going to go up 1 over 4. So let's start with A. Up 1 and then 1, 2, 3, 4. This is your new A double prime. Let's do B. Up 1 and then 1, 2, 3, 4. This is B double prime. And then let's look at C. Up 1 and then 1, 2, 3, 4. This is C double prime. Connect the dots and then we'll see what else we need to do. Okay. What are the coordinates of the vertices in the final image? So you could go like this. A double prime is 3, 3. B double prime is 4, 0. And C double prime is 1, 1. All right, cool. First one down. 3 line segments form the letter N. Rotate the letter N counterclockwise around the midpoint of BC, 180 degrees. Describe the result. Okay, so like 5.8. So we'll go 2.9 is the midpoint of BC. Now this, tracing paper should help. So let me get a fresh one. Describe the result. Okay, so here we go. We're gonna go counterclockwise from this point. So what you do is get A, B, C, D. Write them down. A, B, C, D. Here's our point where we're gonna rotate. Okay, so rotate in counterclockwise 180 degrees. So I need A to end up over here because that's 180. So here we go. I see. It's just going to be the same thing. It's going to be A, B, C, D. It will be the same shape. The same end shape. Except A prime will land on D. You could say C prime on B, B prime on C, and D prime on A. So one more time, here it is. 180, this is 90, this is 180. So A prime lands on D, B prime lands on C, so on and so forth. Okay, there's 2. Okay, triangle ABC has coordinates A equals 1, 3. All right, there's A. B equals 2, 0. There's B. C equals 4, 1. The image of this triangle after a sequence of transformations is triangle A prime, B prime, C prime, where A equals -5, -3, okay? B prime is -4, 0. C prime, -2, -1. Write a sequence of transformations that takes A, B, C to triangle A prime, B prime, C prime. Okay. The first thing I can tell is that if I'm using A, B, C right here, I'm trying to get it in like this orientation where like A is down here, B prime, C. So my first thought is this. Why don't we just draw this real quick to help us? And I'm fine, it's just I lost my voice. Kind of a little cold, no big deal. Hopefully the camera will still pick up my voice for the translation. But anyway, what if we reflect over the x-axis? This is the x-axis, right? Then we'll be here, and it's in the orientation that I need. So reflect over the x-axis and then translate however many units. Let's figure out how many that is. 1, 2, 3, 4, 5, 6. So reflect over x, translate to the left 6 units. So here's a sequence. Reflect over x-axis, translate, and then instead of saying left, you could say translate by directed line segment. And all we need is 6 units to the left. So say from 0, 0 to -6, 0. So every single point would go that directed line segment. Okay, number 4. Prove triangle ABC is congruent to DEF. So why is ABC congruent to DEF? Okay. So let's see. We could do well, there's triangles, so you could do angle, side, angle, side, or side, side. That'd be a way to do it. Yeah, and that's probably the way I'm going to go about it. So AB equals 2, DE equals 2. All right, so we got one side. This one right here, BC, you can use Pythagorean. So this is 1, 2, 3, 4. This is 4. This is 1. So BC will be the square root of 4 squared plus 1 squared because of Pythagorean. So square root of 17. So BC will be the square root of 17. So will FE. Square root of 17. So now we got 2 sides. And then last but not least, let's look at AC. So this leg is 1, 2, 3. This one's 1, 2, 3, 4. So AC squared will equal 3 squared plus 4 squared. There's a little more explanation. So AC squared will equal 9 plus 16. AC will equal the square root of 25. So AC equals 5. Now let's look at DF. So remember, we got a 3 and a 4. So 3 squared plus 4 squared will equal DF squared. So 9 plus 16 equals DF squared. 25 equals DF squared. Square root of 25 equals DF. 5 equals DF. So AC and DF are also congruent, 5 and 5. So there's our third side. So both ABC and triangle DEF have 3 congruent sides. Therefore, I should say 3 pairs congruent side. Therefore, the triangles are congruent. And they're congruent by side, side, side. Okay, 4 down. Also trying to hustle to want to catch the Warriors game, but all right. Density of water is 1 gram per centimeter cubed per cubic centimeter. An object floats if its density is less than water, sinks if it's greater. With a 1.17 gram diamond in the shape of a pyramid whose base has area 2 square centimeters, whose height is 0.5 centimeters, sink or float. Explain your reasoning. So the first thing you need to know is density equals mass over volume. Now we're trying to figure out what the density of diamond is. So the diamond has a mass of 1.17 grams, right? And then we got to figure out what the diamond's volume is. So volume of a diamond, here we go. It's in the shape of a pyramid, whose base equals 2. So don't give up on these just because they're like kind of hard. Height is 0.5 centimeters. So all you got to do is base height over 3, which is easy. So 2 times 0.5 over 3. 2 times 0.5 is 1 divided by 3. So the volume of this diamond is just 1/3. So you're going to get 1.17 over 0.333 cubic centimeters. So what does that equal? Well, let's find out. 1.17 divided by 0.333 equals 3.51. This is the density of the diamond. So if it's greater, it sinks if its density is greater than water's. Density of water is just 1. This one's 3.51, so it sinks. Easy. Okay, oblique cylinder with a base of radius 2. Shown top of the cylinder can be obtained by translating this base by the directed line segment AB, which has a length of 16 units. The segment AB forms a 30-degree angle, the plane of the base, meaning you can draw a right triangle right here. Label this 30, and then we're going to try to figure out what the height is. We need the volume of the cylinder. So we already have the radius. We just need the height. So we're going to color. So 30, label up, hypo. So we labeled. So now we write SOHCAHTOA. Then we're going to look for the one with the O and the H. That's so. So you're going to choose sin, and then you go sin 30 equals up, hypo, all review stuff that you've already learned. Sin 30 equals 0.5, so 0.5 equals height over 16. Cross multiply, 16 times a half is 8, h times 1 is just h. So our height is 8. Okay, so that's our height. Now we got to get the volume. Height equals 8, radius equals 2, and then a cylinder volume is pi r squared times height, so that will equal pi 2 squared times 8, which equals pi times 4 times 8, which equals 32 pi cubic units. And that's your final answer. Okay, this design began from the construction of an equilateral triangle. Record at least 3 rigid transformations you see in the design. Okay, this is weird. All right, I see this first one. Reflect circle center A over line DC. That would be 1. Let's see, translate circle center C by directed line segment CB. I'll take C to B. And then let's see if I can do a rotation. Let me think. Rotation. No, I'll skip rotation. Let's just translate again. Let's go translate circle center B by DLS BA. That'll get circle center B to A. Alright, so that one's pretty easy. You just got to come up with 3 razor transformations. Alright, no problem, 15 minutes.